Exercise 2235 is trying to get you to think about the Malonic ester synthesis, which we introduced and discussed at length in the previous video from the perspective of synthesis. And what we determined in the previous video was that you would always use this recipe here. We discussed what each of these things are doing. And so the ultimate result is that you take an alkyl halide and you add 2 carbons and create a carboxylic acid at the end of that chain. And we talked about how you could read this recipe in 2 directions. You could either go forwards, in which case you'd be given the alkyl halide and you'd have to predict what carboxylic acid you get, or you can go backwards, where they give you a carboxylic acid and you have to think about what alkyl halide you need in order to make that. That's what they're doing here. They give us a carboxylic acid. Now the recipe that we use will always be the same, except for which alkyl halide we use, and how many times we have to do this step. Each step, as we'll see in the next, in this video, in the next exercise. Okay, well, you see that what you add, if you have this alkyl group, what you add onto it are 2 carbons and a carboxylic acid. So in the original molecule, highlight the carboxylic acid and the carbon next to it. That's the group that you're going to be adding. And then erase those. Here I'm going to draw over them in white. So we erase those groups. So what we have left is this 5-membered ring with a methyl group coming off of it. That's our R group. That's this R chain. All we have to add on to that is the halogen. That capital X is either chlorine, bromine, or iodine. Doesn't matter which one you choose. I'm going to use iodine. Any leaving group would be fine. And so you can see how you can use the carboxylic acid they give you to figure out which alkyl halide, what the specific alkyl halide is that you want to add in. And so you can take this specific alkyl halide, have it in your second step, and your product will be what they gave you here. So every time, and so you can sort of draw this in. And there we have our product, which is the original molecule that they drew in. So every time you use the malonic ester synthesis, you will draw out diethylmalonate. Make sure you can draw that molecule. The first step is always sodium ethoxide and ethanol. We discussed why in the previous video. Then you'll always have this alkyl halide that you're doing an SN2 reaction with, as we discussed in the previous video. And then the last step will always be hydronium and heat, which hydrolyzes the esters and diethylmalonate, and then the heat causes decarboxylation. And so those steps are the essential steps for creating this carboxylic acid. So we're sort of doing retrosynthesis here. Given the product, what do we need to make it? This stuff. Now if we kind of go through the same process of thinking for B, an interesting thing happens. We know in general that you would use this sort of recipe here. And actually, let me go back up to the material from the previous video and get this recipe here. So we know in general, as a sort of rough draft, we have this recipe here. And the question, the thing that we tried to figure out in the last one, was what R group do we need for our alkyl halide? We saw that the groups coming from diethylmalonate are 2 carbons and the carboxylic acid. So if we take the carboxylic acid and the carbon next to it, and we erase those, we don't just end up with 1 carbon chain, we end up with 2. And make sure you're erasing both of the carbons, because the diethylmalonate adds 2 carbons, so you erase both. Now we have 2 carbon chains here. That means that we need to add these separately as two different alkyl halides. So we'll have the one on top with the benzene ring, the methyl group, and attach that to a leaving group. Then we have just the one carbon here with a leaving group on it. Because we have two different alkyl halides, we're going to use the procedure that we discussed in the previous video with 5 steps in it. We're going to do the first 2 steps twice. So instead of just having those 3 steps, we're going to do these 5. And notice the difference here. Instead of these first 2 steps, where we create the nucleophile in the alpha carbon and do an SN2 reaction with it, we do that twice. And that allows us to do 2 SN2 reactions and add 2 carbon chains. Our 2 carbon chains over here. And so we can add these 2 carbon chains separately. Now in this example, it doesn't really matter which one you do first. I'm going to add that one first and then this one second. So you always, when you do the Malonic ester synthesis, you always start with diethyl malonate and make sure you can draw that molecule. And we discussed a way you can remember that in the previous video. Then you always start with sodium ethoxide and ethanol. Think about what alkyl halide you need. We already went through the procedure for that here. So we can replace that Rx with a specific molecule. That first one. Then, so that adds this first carbon chain. And then we need the second one. So we use sodium ethoxide and ethanol again to rip off the second alpha hydrogen, like we discussed in the previous video. And then we replace the second alkyl halide with the second alkyl halide that we know we need from our earlier analysis. Oops. And then after we do those 2 steps, we've attached our 2 carbons onto the alpha carbon. The H3O plus does the hydrolysis of the ester, turns them into carboxylic acids, and heat decarboxylates. It takes carbon dioxide off of the diethyl malonate. And so we end up with our product. Now here, the specific R groups will be the 2 R groups we have here. And so, if you compare that to our original molecule, you'll see that that's what we created. So we have this first R group that we added, the second R group that we added, and then the piece that came from diethyl malonate. Okay, let's try that same procedure with C. With C here. Now remember, the COOH is really just an abbreviated way of writing a carboxylic acid. So I'm going to erase that and write in the skeletal structure for that, just so it doesn't look quite as unfamiliar. So that's what that COOH was saying. We have the C, O, O, and H. So that's our carboxylic acid, and anytime you see a carboxylic acid from now on, you want to think, I could make that using the Malonic ester synthesis. I would just use diethyl malonate, sodium ethoxide, and ethanol, and then I'd have to think about what alkyl halides I would need to use in my SN2 reactions. So to do that, when you do this, you remember that in this Malonic ester synthesis, you add 2 carbons and a carboxylic acid. So highlight that in your molecule. There's the 2 carbons in the carboxylic acid, and then erase those. And notice that when you do that, you have 2 carbon chains. So we're going to have to add these two carbon chains separately. Now we need to put a leaving group on these because we're going to do an SN2 reaction. So those are our two alkyl chains. And then we just have to fit that into our recipe. And let me just include those there. Okay, awesome. So now we just have to fit those into our recipe. So this first carbon chain, that alkyl halide, can be the one that we add in step 2. And the second carbon chain can be the one that we add in step 4, that alkyl halide there. It doesn't matter really the order you put them in. And so those will be your two products, or those are the two alkyl halides you need to fit into that standard recipe that you do. We have to do the first two steps twice, once to put each carbon chain onto the alpha carbon of diethyl malonate, and so that will add propyl groups to each of those branches. So you'd have 1, 2, 3, 1, 2, 3. Okay, and so that, if you compare that with the original molecule, that's what we have. We have the COOH, the COOH here, and then basically a 7-carbon chain. 1, 2, 3, 4, 5, 6, 7, and it's on carbon 4. So that's the same molecule that we originally had. So we saw carboxylic acid. We said, I can make those using the Malonic ester synthesis. You always start with diethyl malonate, then you use sodium ethoxide and ethanol, followed by an alkyl halide to put on 1 carbon chain on the alpha carbon. Sodium ethoxide and ethanol, and then the other carbon chain on the alpha carbon. And we follow it up with acid-catalyzed hydrolysis of the ester to get the carboxylic acids, and heat. The heat does a decarboxylation. So one of these leaves as carbon dioxide, and the other stays as a carboxylic acid, as we drew in the previous video. Okay, let's think about D. We see a carboxylic acid, and now from now on, whenever you see a carboxylic acid, you want to think, I could make that doing the Malonic ester synthesis. So you draw out diethyl malonate, and then you would start drawing out the standard recipe. So the first step is always to rip the alpha hydrogen off of diethyl malonate with this sodium ethoxide and ethanol. That turns that alpha carbon into a nucleophile, and you just need an alkyl halide for it to attack in an SN2 reaction. Now the ultimate thing you're going to do is add a carboxylic acid and an alpha carbon onto your alkyl halide. So if you're looking at your carboxylic acid, look for the carboxylic acid and the alpha carbon. That's going to come from diethyl malonate. So the first step is to erase that. The carboxylic acid and the alpha carbon. And what you'll notice is you have 2 separated carbon chains there. So you want to draw those separately and fill them in with a leaving group. So we'd have, for example, this carbon chain with a leaving group on it, and the other carbon chain with a leaving group on it. And because we have 2 separate carbon chains, we have to do those first 2 steps. We have to do those first 2 steps twice. Once to put each carbon chain onto the alpha carbon of the diethyl malonate. So instead of this just normal Rx, we will have our 1-bromopropane. Instead of the second Rx, we'll have our bromomethane. And then those 2 steps will be followed up by the acid and the heat. Acid does the acid-catalyzed hydrolysis, and the heat does the decarboxylation. And so you'll notice, if you fill those in, we'll replace the R groups with what we have. We have a propyl group, so 1, 2, 3. Oops. And then on the other one, we just have a methyl group, so 1. And you'll notice that that is the same molecule as the one we have up here. You have the propyl group in orange, the methyl group in purple, and then the alpha carbon and the carboxylic acid. So in general, whenever you want to make a carboxylic acid, always start with diethyl malonate, if you want to make it in this way, and then always sodium methoxide and ethanol followed by the alkyl halide you want. If you're trying to add 2 carbon chains, when you erase the carboxylic acid and the alpha carbon, you have 2 carbon chains, then you do that procedure again, sodium methoxide again, with the other alkyl halide. And you always follow up with the last step of aqueous acid and heat. Okay, now remember, in this video, we're looking at this reaction from the perspective of synthesis. So if you're just trying to learn this as random patterns, it'll be really hard to remember. So I encourage you to go back and watch the previous video that explains what role all of these are playing. So you see these separate molecules as characters in a story that's easier to remember than it's just random lines and letters that you have to memorize in a specific pattern. Now, just for the sake of time, we're approaching this as patterns, solving patterns, but these patterns will really make more sense if you watch the previous video on the concepts and mechanism behind this reaction. Okay, so here we have another carboxylic acid, and from now on, when you see a carboxylic acid, you want to think, I can make that from alkyl halides using the Malonic ester synthesis. And what you do is you basically have alkyl halides, and you add a carboxylic acid and an alpha carbon onto them. So here, highlight your carboxylic acid and your alpha carbon. That's going to come from diethyl malonate. So when you're trying to think about what alkyl halides you want, erase that, because that's not going to come from the alkyl halides. Now when you erase those, you see that you have 2 separated carbon chains. And so you redraw those chains, but with a leaving group. I'm going to use iodine. Now that we have 2 alkyl halides, we know we have to do that first step twice. Once to put each alkyl halide onto the chain, onto the alpha carbon of the malonic acid, diethyl malonate. So if we have our first alkyl halide and then our second alkyl halide, so we can replace this Rx here with this first one. We can replace the second Rx with our second one. And there we have our recipe. Now, we'll replace these R groups with our chains. And there you go. Compare that with the original molecule and you'll see it's the same thing. So you have this group at the bottom, you have this sort of isobutyl group to the left, and you have your 2 carbons with the carboxylic acid on them in the middle. So anytime you see a carboxylic acid from now on, you want to be able to think in your mind, I can make that from diethyl malonate using this recipe that we have here, repeating the sodium methoxide and ethanol and the alkyl halide, either once or twice, depending on how many alkyl groups you want to attach to that alpha hydrogen, or alpha carbon of the carboxylic acid. And then at the very end, treat it with hydronium and heat to do the acid-catalyzed hydrolysis and the decarboxylation, as we discussed in the previous video. So hopefully this video helps you a little bit with thinking about how you can use the malonic ester synthesis to create carboxylic acids. Just sort of retrosynthetically think about how you can make carboxylic acid.